Bubbles and carbonation are an important part of enjoying a beer. They add to the olfactory experience by releasing volatiles, offer a light experience on the tongue, avoiding flat beer, and allow retention of the foamy head. We'll be discussing the chemical processes that govern bubble formation and how to promote these processes. Bubbles are formed through nucleation. Nucleation is the initial process in the formation of a new phase. While it might be favorable for material to be solid, liquid, or gas at a given temperature, the material has to overcome the energy barrier to switch phases. To create a new phase, a group of molecules must coalesce and stabilize to form a site upon which additional molecules are deposited. These will grow until all the material has been changed to the new phase. In beer, this phase change involves the nucleation of gaseous carbon dioxide or CO2 from the carbon dioxide that is dissolved in the beer. If there is a large enough pocket of gaseous CO2, the molecules will stabilize and form a small bubble. Once these bubbles are formed, they float to the top of the beer due to buoyancy. Determining whether a bubble of CO2 is large enough involves minimizing the energy of the system. The formation of the bubble creates a high energy interface between the gaseous CO2 and the rest of the liquid. At this temperature, the CO2 would save energy by being a gas. There has to be enough energy saved by switching to gaseous CO2 to overcome the surface energy created by the bubble. This energy trade-off happens at a critical bubble size. Bubbles below this critical size will collapse and redissolve. Bubbles larger than this will stabilize. One way to make smaller and more bubbles possible is through heterogeneous nucleation. In this nucleation process, bubbles form on surface flaws. These flaws offer a good place for nucleation because they have a very high interface energy. Creating a bubble at the flaw reduces this energy, as the bubble interface energy is not as high as the flaws. In designing glasses, we want to maximize opportunities for nucleation. This is accomplished by etching the bottom of the glass. This creates heterogeneous nucleation sites that make it energetically favorable for a bubble to form, making for a better drinking experience.